Hi guys, it's Oli here. I hope you're having a great day. I'm back with another video on the Mavic Mini battery hack. In today's video I'm going to attempt to replace all the electronics on the left with smaller components so that it can fit under the factory cap on this battery. And this video will not make too much sense if you haven't seen my earlier ones in this series, so check them out to fully grasp what is going on here. So I remove everything I can from this battery first to free up the PCB and get on with the procedure. In my earlier video I said that I am planning to remove these two MOSFETs because they take up space and just give additional weight and they are not in use anymore. So this is what I'm doing here. This took quite a heating. Of course this is sped up and cut, but eventually it is possible to remove them. The second one has to be heated from the top, from that side, and then somehow it comes off. Of course the resistor network has to go also. They are still too big for my purposes now. I have both SMD resistors also for this. So now I clean up the PCB. I will not bore you with that, it's cleaned up. A lot of flux, so I remove it with some acetone. Now it starts to look like something possible to work with. Because of course I have to put on a new resistor network. And it goes like this. On the left side there is the positive terminal. I outlined the negative terminal there and the balance. And there goes the two 10K resistors. So I start to scrape up the paint. So there is something to solder to. And there goes the first 10K resistor. It's in. It's not super easy to solder these small components, but it is possible. Anything smaller than this, I would not even try really. And the other 10K resistor goes on the positive terminal of the battery pack. Just slightly. That's all it takes really. But it takes quite well. And then of course it has to be connected to this balance point in the middle with a small piece of copper wire. That is actually an insulated wire from a very, very small transformator maybe or something like this. So that's the resistor network done. As you can see, it's not fully in balance, but it will do. The components originally, in my earlier video I said they will weigh around half a gram. I bought smaller components now, so it's 0.25 grams. That's great. I reconnect my bypass leads because there are no MOSFETs anymore. And here is the voltage regulator as the first to do, and the super glue, of course. I glue the voltage regulator on the top of the PCB upside down, because like this, the pins on the voltage regulator are further away from the PCB, easier to solder to, easier to isolate, whatnot. I will do with all the components this way, basically. This is the thinnest wire I have at home. It's from an old IDE ribbon cable. And then I connect the voltage regulator positive to the positive terminal, ground to the ground, and the output of the voltage regulator I'm going to connect later to the microcontroller, which is the ATTINY85 on the left. Also upside down. As you can see, one pin is also bent up because I needed space there. The MOSFET also goes upside down. And with this, in this position, I can, as you can see, I can solder those two pins to the microcontroller. Now this is very, very tricky. So I just tape down the micro. And yeah, eventually I get it done. It was really small. But this is how it is. And you see the bent up leg is not connected. For the insulation I use Captain tape. This is the thinnest which I have. Normal electrical tape is way thicker than this, so this will prevent any shorts or whatever, just to protect a little bit the PCB, just for safety. Alright, microcontroller is glued on, of course with super glue. And then I start connecting up stuff. This is one of the trickiest soldering part, because on that pin there is the microcontroller and one pin of the MOSFET also, and one wire. This is going to be one of the data wires going on the left pin on the battery connector. I will not solder it now, because I solder other stuff first. Here is the other part of the data connection. This was the pad we soldered on in the first or second video maybe. And this goes on the loose end, the loose pin of the MOSFET. Everything is going to be explained later. There will be a wiring diagram, so don't worry. It's easy to understand what is going on. I just want to show the procedure. And now, of course, the microcontroller needs supply voltage. 5 volt DC is coming from this voltage regulator. So that's the output pin of the voltage regulator, and it is going to be that pin to the lowest pin there on the micro. That's the VCC on the ATTINY85. And that's connected, so theoretically the microcontroller will be able to operate. But it first needs a ground, so I pick that ground pin on the battery connector and connect it on the ground pin of the microcontroller. And this is the data pin I told in the beginning that it's going to be connected to, the tricky one. And of course it needs a push button to start, so I glued that on the top of the micro, which is the belly of the micro. And this pin, one of the pins, are connected to the button sensing pin. I think it's digital pin 3, and the other one to ground. And then ready to put it together. So the cells are back. I'm just reconnecting this bypass leads, and essentially the soldering work is done. Of course I programmed the microcontroller before, so this is how it looks. Let me explain. This is the voltage regulator. Those are the pins, you can see. Everything is belly up. Everything is belly up. This is the microcontroller. Those numbers are the physical pins of the microcontroller, so not the digital pins per the Arduino setup. It's important to know. And here is the MOSFET 2N7002K. This is the smallest package I think a hobbyist can actually solder to, this SOT23. These are the leads for the voltage regulator, and of course the micro needs the ground. And here are the data pins in orange. This is actually what we manipulate. This is why we do the whole project. And then something needs to start this whole operation, and that will be with green, the push buttons. This is all actually. You can pause if you need to. And here is the reassembled battery, lid on, drill. I drilled the hole for the push button. Now in my earlier videos I said that I'm trying to do something with the series connection on the bottom of the battery, so it doesn't need to be soldered all the time back and forth. This is what I came up with. Basically a row of pins, twice 3 pins, and a row of jumpers soldered together, so it acts like a bus bar. Basically it connects every pin together. So I soldered these pins on the bottom of the battery, and theoretically when the bus bar is connected to the battery it will be in series, so the battery is operational. This is how it looks, and yes, it actually does work. I tested it, it deals easily with the current needed, so it's fine. Now let's see if we met our weight target. So 50 grams is 50 grams on the scale, so the scale is calibrated. Here comes the drone. That's the empty drone. 150 grams, yeah, it's standard fare. This is what it weighs. And here comes the battery. Let's see. 246. Yes, we made it. And even the SD card is inside the drone. So it is legal to fly if it flies. Let's see. I put in the battery. At least we know it turns on. Now I'm waiting for the LED on the back of the drone to be solid red. I explained this in my earlier video. Really check if you haven't seen it. And now I can press the button to make the microcontroller to start its job. And after 9 seconds, the drone is ready to take off, hopefully. Let's see. Oh, the door. Click and it is possible to close and it starts takeoff. Bye bye. No, I'm kidding. Look at that drone. It looks like new. It acts like new. Could you tell the difference? Could you tell that this battery was actually hacked? Guys, I have to tell you honestly, I think for my purposes now, this battery is done. It's unlogged, it's revived, call whatever you want it to. It is not unlocked, it is still a locked battery, but it works normal. It says normal. That's why it says it, I guess. Also, telemetry data is working. The battery cell voltage, as you can see, temperature, everything. I can take off, I can land, I can take off again. Isn't that how a drone should work? I think so. Can I make this any better, you think? Here is something I haven't done. I talked about it, but I haven't done. I replaced the cells, finally. I did replace the cells with some Sony VTC6 cells, and we are still in weight limit, which is actually amazing. 248, and still, of course, with the SD card in. There's the counter. I started already. I will take off exactly at 1 minute, so I will have to reduce that at the end. Now I have to honestly tell that these VTC6 cells, these Sony cells, are actually not brand new. I bought them around 2 years ago and they have been cycled for 30 times, 40 maybe. So they're not brand new cells, but I'm also very curious to see how it will operate. So ready to take off, just waiting for the 1 minute mark and throttle. Okay, so I'm gonna speed this up a lot, but I want to ask you guys, are you interested in seeing more battery tests, like different cells? Of course, I'm not going for world record. There is already a world record on YouTube. You can check it. It's 82 minutes. It's an amazing video, actually, very informative. But maybe test some other cells, some 21700s even. I don't know. Let me know in the comment section if you want it. So now at 22:30, I got the low battery warning. So this is also good for you to know that with this mode, this hack, this kind of stuff are still working. You get the low battery warning. Now it's forced auto landing. I'm just keeping it up with the throttle. This is actually something I don't really like, that the drone does this forced auto landing. I will have to see if there is something possible to do with that to turn that function off. So essentially 31 minutes. Well, it's not extraordinary from a 3000 milliamp hour battery. So I have to see, is there any way to get more joy out of this drone? Because maybe not bigger, but more batteries. This is a homemade battery with a homemade connector, an adapter, so it can connect to the battery. And here is all the electronics, including the original PCB outside the drone this time, which can be even detached. And the drone is flying. If you see the counter, it is higher now. These are the same Sony cells which I used before, but at this time this forced auto landing thing is disabled, so I can fly the drone as long as there is juice in it. And that's obviously more. In the next video, which is going to be probably the last in this battery modification series, I'm going to show how to make any number of these batteries which can be used with the drone, and also how to get rid of the forced auto landing function. I'm posting videos every Thursday about drones, hacks, modifications, electronics. So if you have any electronic project in mind which you would like to see a video about, please just leave a comment and tell me about it. I'm very curious what my viewers are interested in. And guys, how about to like, share, or maybe even subscribe to my channel? Thanks for watching. Bye guys.